Alright guys, welcome to 6.2a. We are going to be looking at combining random variables. Or, this isn't 6.2a, it's 6.2b. Alright, we're going to be looking at combining random variables. In 6.2a, we looked at manipulating our data by adding, subtracting, multiplying, dividing constants. Today we're going to look at combining two different sets of data. Alright, let's talk about Crazy Pete and his Jeep tours. Did you guys know he has a sister named Erin? And she also runs Jeep tours in a different part of the country, which makes them independent of each other. Okay? Her number of passengers are 2, 3, 4, and 5 at different probabilities than Pete's. Okay? So we might ask ourselves, what would happen if we combine their standard deviations? What would happen if we combine their means? Alright? Well, the nice thing is, let's look at this. Let's say we want to know what they are together. So what's the sum of x and y, where x is Pete, y is Erin? We might now want to know what's the difference. Who's better? Is it Pete or is it Erin on a selected day? Let's figure out how to do it. Let's go. Adventure time. I'm still learning this. Alright. So, I'm going to use these formulas. The expected value, the mean, if I'm adding two random variables, is right here. My mean of s, the sum, is equal to the mean of x plus y, which is equal to the mean of x plus the mean of y. You just add them together. It's that easy. Okay? But wait, what do I do if I want to find the difference? Good question. I'm looking for the mean expected value of a difference, so I'm subtracting my data. I subtract my means. It's that easy. Okay? So, you guys got it? Pause if you need to. Let me keep going. Now, Pete charges $150 per passenger. Erin charges more. Erin's not very nice. Okay? If C is the amount of money that Pete collects, and E is the amount of money Erin collects on a randomly selected day, we know that the mean of Pete's money is $562. And we can find easily by doing our probability times number times amount of money that the mean of money made by Erin is 542.5. So let's find out what is their combined income and interpret that. Alright, so let's do it. We got this. You got... I don't know, I might get sued by somebody if I do that. Hold on, let me grab my piece of paper. Alright. So let's find, what's going to be my mean of S? Well, I'm going to find my mean. It's going to be my mean of C plus E. Right? Which is my mean of C, B. We just add together the means. Well, Pete's mean was 562.5. Erin's mean was 542.5. We add them up. I don't know why my writing's all crooked today. It's just I'm as crooked as a dog's hind leg, as Mr. Tamlin would say. And I got $1,105 is their average amount made. Let's see if they agree. They did. We did it, guys. So we just add up the two means. Now, interpret. We combine them. Pete and Erin expect to collect a total of $1,105 per day on an average day over many randomly selected. Remember the law of large numbers. There has to be a lot combined. Okay? There's sampling variability. You can't just say, every time it's going to be about $1,105. No, over time, we take a random day, it'll be $1,105. I don't know why you talk like that. It's goofy. Alright, let's look at Erin's adventures and Pete's adventures of just their number of people. So now we have the mean and the standard deviation. Let's deal with that standard deviation. So we're going to define x as the sum of Pete and Aaron. It's still going to be s is x plus y. Oh, I'm actually going to skip this. It's the long way to do it. If you really want to learn how to do it, you guys can. I'm going to give you guys a shortcut. Here's the shortcut. It's a formula. Why am I doing this? Why do I talk like this? All right. So the mean, the standard deviation, the variance between x and y, if we combine the random variables, we take the standard deviation of one and square it, and we add to the standard deviation of the other and square it. Oh no, Moby, no, mouse. And again, and then we square root that to get the standard deviation. All right. Oh, I can just do this. Touch screens. Let's go. All right. Know that formula. You square them, add them for the variance, square them, add them, square root them, and the standard deviation. All right. Y'all good? All right, cool. Let's try something, y'all. Why you know we're good? Hey. So when you add two random, independent, they have to be independent variables, we add their means. They act nicely. With standard deviations, we have to square them, then add them. They do not act so nicely. All right? Keep that in mind. Let's try it. So here's Pete's Jeeps. Here's Aaron's Jeeps. Here's our variance. Here's our standard deviation. Here's our variance of y. Here's our standard deviation of y. So how do we find the difference between them? Easy. We square them, we add them. We square them and we add them. Then we square them, we add them, we square root. That's not what your standard deviation gets bigger. Okay? Because we're adding two non-homogeneous groups. It's not a typo. Because when we square them, we add them. And down here, how did this work? Because we square rooted it. Okay. We did it. All right. So let's do this problem. So Aaron and Pete on their adventures in the wilderness, calm down. They have a standard deviation. They have different standard deviations. So we want to find what happens when we combine their data to the standard deviation without having to calculate longhand like we would have done earlier if I was good at my job. Okay? So, let's go. Alright. Moby, no! Now you worked, you fool. So let's think about this. So we take the standard deviation of Pete. By the way, pause. Please pause. I'm going to pause. Alright. So that's the state. Please pause, read the questions. Don't come to me and be like, I have no clue what's going on. Alright, so there's Pete's standard deviation. Here's Aaron's. D is going to be C minus E. So the formula for that is we take them, we square them, we add them. Okay? So to find D, we take them, square them, we add them. Alright? So we do a 163.46 squared plus 165.03 squared. And that'd give me my variance. I square root it to find my standard deviation. Alright, let's see what number that is. So let's see if we did it right, y'all. We did it! I is so proud of us. Square them, add them, variance. Square root it, standard deviation. So the difference in the amount collected on a randomly selected day varies by $232.28 from the mean difference of $20. That's a lot. That's a lot. I think we might be done though. Oh, here's something cool, neato. If you combine normal random variables, they're still normal. If you combine independent normal random variables, they are still normal. Okay? We'll use our formulas to find the mean standard deviation. Just know they're still normally distributed. Okay? Oopsie. So pause this, read it. You have cups with different means and standard deviations, correct? And they want to know what's the difference between the two cups. So let's describe the distribution. The one's normally distributed, the other one's normally distributed. Okay? So, guess what? The shape will be normal. To find the mean, we subtract the two means. You'll have no idea what I'm talking about if you did not read the question. Pause it and read it, people. Alright, sorry. Calm down, Mr. William. Calm down. The sun is not shining, but the world's still fine. So I do 398, or minus my 396. Now for standard deviation, we square them, add them, square root them to find our new standard deviation. Going pretty quick, but I think you guys get them. We'll be doing this in class. This is new. Pause it, read it, interpret. Alright, so now we're going to use the information we found to answer this. So for a lid to fit on the cup, it has to be L bigger than the value of C. Okay? But not more than 0.06. It'll be all floppy and fall off then. So what's the probability that a randomly selected lid will fit on a randomly selected cup? Interpret the value. Okay? So it has to be bigger than C, but not bigger than 0.06 inches in C. Okay? So think about that. So, oh, that's went way too fast. Ah, jeez. All right. So think about this. When we did our calculations before, we got 2 as a mean with a standard deviation of 0.024 or 0.0224, right? So our normal curve, our mean starts at 0.02, and then we add 0.024 or 0.0224, and we subtract it to get our normal curve, right? So for us, the cup can be from 0. That's too big. From 0 to 0.06, right? Agreed? Now I wouldn't do it this way. You can do it that way. How would Mr. Twilliger do it? Good question. It's normally distributed, so we're going to use our normal CDF. Normal CDF, left bound, right bound. Zeros are left bound. 0.06 is our right bound. Our mean was 0.02. And our standard deviation is 0.0224, which we found from our subtracting our means, and we found it from squaring and adding our standard deviations and then square rooting them to find that standard deviation. Okay? When you do that, you'll get 0.7766, which would be the probability that a randomly selected cup is the right size. Let's see if they did it that way too. There you go. So there's a 77.7% chance that randomly selected cup fits a randomly selected cup. Lid, cup. Have a good day.